We are live. So are we doing the mechanical? You're muted.
Yeah, we can. Let's see if I can warm up and stop being rusty with Onshape. It's been a year since I tried to design anything. I was trying to design the simplest possible uh, camera mount I could think of. So let's see if we can do that. So let's start a sketch here. Let's see. So simple passive mount with. Can you guys see my screen?
Yes.
Yeah. So it will be 1 degree of freedom, right? Like
0 degree
left, right.
of freedom. I'm not even doing the. Sorry. Oops.
What is the constraint or problem you're trying to deal with?
So basically, we had the camera on the tumbler, right? So
Right.
when we were in Bangkok, we had used double-sided tape to stick it onto
Sounds good
the.
to me.
So we are trying to improve upon that.
What's the problem with double-sided tape?
It's terrible.
Uh, it just keeps coming off. Yeah,
Oh,
that was the
you
problem.
need better tape. Okay.
And I mean, you do want a more robust build eventually, so you can't stick with double-sided tape forever. We have to do something similar for the. Um,
Yeah, because the double-sided tape loses strength after a while, right?
I think 25 millimeters is fine.
Yeah. That, there are definitely parts in my car that are held together with double-sided tape, and not that I put in.
All right, let's see.
So how do you know the dimensions of these?
Oh, you can dimension it later. So a
Okay.
good practice is to just. Uh, oops, did I do this? Oh, sorry. This is not what I want. I want to see sketch. So I'm going to sketch on this plane and normal. So let's see. I'm trying to. I don't know if the idea of what I'm trying to do is clear, but oops. I'm not going to try and do like a. Let's do an extrude. Remove material, if I remember. Remove. Uh, Depth. Okay, that's not quite right. So the idea I'm going for is this fork-like part will just go over the board, and we'll drill a hole here and like drill
Hmm.
fasten it with a screw. And then the dimensions are all wrong, but the board can slot into it. Does that make sense? Let me get the dimensions a little better. Okay, so you were asking how to do dimension. You see this icon up here. You click that, click the
So,
part you want to dimension,
uh, w-
and maybe
so the
select.
slot that you have here has to be very exactly sized to the thickness of the board.
Yes, so that's not hard. The idea, the key part is getting the idea correct. Uh, all right, but clearly, all right, this is super constrained. Dimension this as well. I think this is going to be very boring as I warm up. 67 millimeters is too much, probably. That's around 6 centimeters. So this is probably more like 50. Let's do 5. Oops. Right, I'm doing a terrible job here. Hold on. I should just start from scratch again. I'm just going to delete this. Let's delete. Let's start again properly. Be normal to this plane. Let's make it a little bigger. And let's start a sketch. Okay, so pick this plane. All right, this time I'm going to try and draw more carefully.
So that's specific to the tumbler, right?
Yes.
You know, if Anuraj chooses a different supplier and the board thickness changes by, 0.5 millimeter.
Yeah, that's not hard to account for. Since we do 3D printing of everything, we can.
And the PCB thickness and all that stuff is kind of standard. So there are like standard thicknesses.
There's so many standards.
Yep. Okay, so this is slightly better.
Yeah, but it looks very weak, what you're showing. It looks like it has a nice failure point.
What do you mean? The sharp corners, or it's just very thin?
No, the inside corner.
Oh, yeah, that we can fix. We can put in like little curves there, chamfers and things. I'm just doing the basic idea now. Let's do how long?
How does the camera itself connect?
With a USB.
No, I mean,
So
how
you-
does it connect to this L-shaped piece?
Yeah, I'm getting there. Hold on.
Okay.
So this clippy part would go over the board, and I'm going to like design a slot to go down this that you can just slide the USB down. That's the idea. Does that make sense?
So this clipping, that groove, that will go inside on the tumbler,
Board,
the
yeah.
transparent. Yeah.
Yeah, and if we just put a single hole in it, the weird idea I had was just have a single hole with a slightly loosely fastened screw with a not fully threaded, so it can basically pivot on the joint, but we make it frictional, and then we can add like arms to the side of this whole fixture, and yeah, to turn the angle of the camera, it can simply like bump into something, like use obstacles as a way to steer itself. So I thought that would be a fun thing to try. That's
So it would go here on this board.
what would go on.
This edition,
Wait,
whatever
but
you are
it's
designing,
centered.
will
Yes.
it like fit on this?
I mean, yeah, I mean, we'll dimension it.
Yeah.
And right now. I'm just trying to show the idea. For some reason, it keeps switching between tangent arcs. This muscle memory really goes away if you don't use it
Yeah.
regularly.
Yeah, I can. Like I have a similar feeling with the KiCad
Mhm.
buttons. Like after you don't use it for a while, then you are trying to remember, and that's why all these service design companies from this PCB manufacturers, they hire a lot of engineers who are basically like skilled in that, so they do it really fast.
Okay, is the idea at least clear now? What I'm trying to do
Yeah.
here? Okay,
Yeah.
so that would clip over. We can make a little hole here. Let's make a million sketches to do these things. Uh,
Uh, the USB comes from the bottom, so
okay, so we can All right, let's actually fix that first then. I do have. Okay, I have a lot of crud from the previous crap attempt. Okay, cleaned up a little bit now. All right, let's first take this extrude and increase the depth. I think it needs to go down to maybe, I don't know how deep that is, but just to make it slightly more realistic looking. Okay, that looks better. And I think the way to do it would be to make a hole on this surface.
Or on the back, perhaps? No?
Actually, let me pull out the camera and see what it actually looks like.
Well, like if I remember correctly, we can just plug it in inverted, and then so you can
Just invert the image then, right?
yes. So basically, I think there is some setting to get the image in a particular direction. So we could just not have the hole at the bottom, and then plug it in, or like put it inside the socket with the USB facing upward, and then we get the photo or the picture in software in the correct orientation.
Yeah, we can do
Yeah, but
that.
that's expensive.
Yeah, the easier way to do that, I think, is to just make the design agnostic to direction. So in this form, it can go on the top, and we can like just make a hole in the bottom, so we can just install it either way, I think.
You can't just make a hole because the plug has a widening. You can make a slot on the
Yes.
bottom that you
This would
push
be
it in
about 5
laterally.
millimeter. That's. Oh, I mean, I'm trying to like manipulate it in the StreamYard screen. Okay, let's. All right, that's the view normal to sketch plane. Okay, let's make a slot. This looks like it's about 10 millimeters wide, which should kind of do the trick. Actually, no, let's escape rectangle. I should do it more systematically. I'll use a center point rectangle. That way I can hopefully align with the center
What
line.
is a center point rectangle?
So you can you get it, right? It's
Yeah.
corner to corner or center line. This makes it symmetrically positioned, so this is better. So let's see, this is now 12 by 4. It'll make the corner really thin, so you don't want it weakened too much. So let's do that. And let's do a remove, not blind, but through all. And that's it. All right, so now there's a hole in the bottom. This will actually be a mess to print if you think about it. Like if you try to print this on a 3D printer, it's going to print supports. I would print it on its side.
Side, yeah.
Actually,
But
no,
it's
I would print it in this L orientation. This would have supports, and then you would just remove them with a file or something. The other idea would be, no, I think it's not too bad.
I think printing on the side would require less support because the overhang is smaller, right?
Yeah, that hole is small enough. I think it will require no support, and this upper slot may require support.
But one problem though is that it's a mini USB, right? And so
5 millimeters or so wide.
the end, you may have, maybe it's fine for the cable, but if this is too big for the hole, okay, it may become weaker, right? If we need a bigger hole.
Yeah, I think for mini USB, this is fine for, and this whole thing we can kind of like increase the width and like add strength in any dimension we want. This is just the lightest idea I can think of. And internally we can, you'd have to tighten the dimensions. I don't know what the mounting options are here. There's one mounting hole, I think. I'm looking at it right now. There's just one mounting hole to the top left if you look at the board from the front. So we can have one restraining screw. If you look, I don't know how well it's clear. Can you see there's one hole at
Yeah,
the
yeah.
top left? We can put a tiny, I think it's an M2 screw we can put there. And yeah, the bottom will rest on that ledge effectively. That should be enough. And yes, we can still put some double-sided tape to hold it in the slot if necessary. But then it's not the main load-bearing part. And yeah, the last thought I had was, yeah, let's finish this simple design. Let's sketch here. You know about a sketch plane, and let's make a hole. So we'll use a center point circle. And let's see, we want it centered from this side. So this, I'm not going to make it symmetric because this will depend on where the available holes are on the board. I haven't looked at that yet, but this is just to give an idea of what it'll be like. Remove wall. Yep. So this is camera mount design number 1.
Okay, do you want to put some strengthenings on it?
What
So-
things?
Things to strengthen it so it won't just snap at the corner.
Okay, so the way I'll demonstrate one way you can do that, which is you pick a sharp edge, which will be a stress point, and then you add a chamfer or a fillet. Not a
Yeah,
rib.
you can add a big chamfer here. No, a big fillet.
So that'll strengthen it. And we can do similar to other stuff as well. Yeah. So design number 1. Oh, I might as well demonstrate the idea I had in mind. So
Yeah, can you make something bigger like buttresses?
buttresses, yes, you can. That's I haven't tried that. I think this I think this is called a rib. So let me undo this and let's try what a rib looks like. I actually have never done a rib. Oops. Rib. Actually, I think I have to sketch something or something. Parallel to sketch plane. Normal to sketch plane. Okay, I'll have to look up documentation on how to do this. I don't want to try this now. So I'm just going to go back to the chamfer. But I'll show you guys the one idea I had, which was let's see. So something like extrude, say, all right, so now it has a kind of wing, and then we can add like an extension. Let's see.
I also don't like the way we're locking it in with the screw. When again, it's if you're a little bit inaccurate on the distance between the screw and the edge, then the thing will be floppy.
Wait, what? If there's a little bit.
You're putting it on the board and then you're screwing it in through that hole.
Yes.
Now, if the dimensions of the board, the distance from the wall to the hole, are imprecise, or if what you 3D print, the distance is imprecise, it's going to be rocking right and left.
Yeah, so what you would do then is make it a slight interference fit so that it fits snugly. But the reason actually to do a single hole fastener is in fact to allow for play. That's the idea behind this design. So I'm only drawing one side. You can symmetrically mirror this. But the idea is if you want to turn the camera on the yaw axis, you would just go bump into something with this like fork-like thing in the front, and it would turn it because the screw would not be fully tight. We would leave it some clearance. So you'd have a similar arm like that. And I haven't yet thought it through, but I think it's possible to cleverly design a completely passive mechanism that can get at least 2 degrees of freedom simply by bumping into things. So that might be a fun design to try. But yeah, if I
Now,
add,
what is this
Scratching your
wing?
nose on the wall.
what?
It's like the equivalent of scratching your nose on the wall if your nose is itching.
Yeah, exactly. That kind of thing. So the advantage is you don't have to have another motor,
Yeah.
another control line.
No, I didn't get what this wing structure is for.
So if you fasten this mount to the board with just a single screw and the screw is not fully tight so that it can actually rotate along the screw, then but it's slightly tight. It's not completely
Yeah,
loose.
yeah.
Yeah, so you would go bump into a wall using this side fork, and then that would just turn the camera. So say you wanted to do like a get into like a narrow space where you have to look slightly sideways, but you don't have room to turn the whole rover. So what you might do is go bump the camera a little bit and then go in with the camera tilted. Does that make sense?
Okay. Yeah. Okay.
It's a weird idea, but I'm kind of curious to see how much you can do with just completely passive mechanical design. So I was trying to think through how many degrees of freedom can you do. So obviously you can do this in 2 dimensions. You would add like another passive joint and you would be able to move, I think, up and down. So the pitch axis would also work.
But then how do you get back to the original orientation?
Yeah, so you'd put another symmetric one on the other side. So you would just bump the other way. So this is easy to do in the yaw plane because both will be like hands that are horizontal. In the pitching plane, it'll be harder because it'll be easier to bump into things that are low than things that are high. So for the putting it back, you would have to have some kind of leverage mechanism. But for 1 degree, I think this would actually kind of work. So you can do without a motor, or this can be a backup mechanism. Even if you have a motor, but the motor dies, you can still use this mechanism to like move the thing. But yeah, so that's my little design exercise. I will design a version of this and print just to have something extremely basic. But the real design I want to do would be an SG90 motor with 1 active degree of freedom. So just the same axis, but 1 active degree. But if you wanted a completely fixed camera, what we could do is I'll look at the hole patterns on the tumbler, and we can drill new holes if necessary, but we can add a second hole. So if you want a stationary camera, you would just put down 2 screws and like completely lock it down. But if you want the passive rotation possibility, you would just use 1 screw, something like that.
How do I print this then once you are done?
I'll send you the printable file.
Okay.
Yeah.
And like if I want to make some modifications, I might go through this again and try to make some.
So this is this is a public file. Since I have a free account, I can only make community files anyway. So I'll give you the link, and yeah, you can make a copy of the drawing and adapt it. But yeah, this is idea number 1. Idea number 2 would be an SG90 motor, since that's the one I have, that would have the same axis, similar holding fixture for the board. But this one instead, what would happen is this thing with the hole, I would move it up to midway to the holding fixture and then mount the hole on the
on the motor.
Yeah, the motor axis. Yeah. So that way it just becomes actuated. And then the motor has 2 holding screw holes. So you can just bolt the motor onto the board. Anyway, so that's basically it.
So how would you do it actually for the vertical, what do you call it, pitch?
Yeah, so the passive one, you mean?
Yeah.
So tilting it forward is not hard. You would just have like a similar long thing.
No, I mean, how would the connector look like?
Oh, that would be, I can try and quickly, let me.
Because this connector here is stabilized.
Yeah, you would just have like Let me actually see if I can show you with Legos. Let me stop sharing. Legos are useful demonstration things.
Well, yesterday I saw university labs that build test equipment out of Lego.
Yeah, Legos are really good for very quick prototyping. If they were less flimsy, you could do things with them. But yeah, here's a kind of like, you would have a fork like this that would be vertically oriented on the board. So if my hand is the board, you would have this like this and the fork, and then you'd have like the fixture mounted to pivot on that axis. The axle would be through this.
Okay.
That would be the.
So
It would
you
be
add another hinge, but then you have the problem: how do you make it rotate on one hinge but not rotate on the other?
So all these would be friction joints, so they'd be tight enough that unless they're like pushed with a certain force, they would not move, right? So only the one you're bumping into would move. So if you have two side wings and then two vertical wings to do the vertical movement or pitch movement, you would only try to bump one thing at a time, basically.
Oh, that sounds a bit tricky.
I know. This is just a weird bunny trail I was going down into passive mechanisms. Because I think one of the interesting things is the maximalist version of this kind of thing. Like think about the maximalist camera fixture you would want to do. I would want to put it at the end of like a full manipulator arm so that it has full 6 degree of freedom, rotation, three translation, probably actually more like +1.
You could just use a small gimbal, right? 3-axis gimbal.
I would actually do more. I would do 9. I would put the 3-axis end effector on the end of like a 3 degree of freedom arm. That way you can like actually move your arm below and examine the undercarriage. If your wheel breaks, you can like diagnose faults and stuff. So the camera becomes like, we can do that with our bodies.
But with no motors.
Hmm?
But with no motors.
No, with no motors, I think you're screwed. If you try to do more than 2 degrees, it would be like weirdly Rube Goldberg complex. I don't know if it's even possible. But yeah, more than 2 degrees of freedom, you'd have to actuate the joints.
No, you don't have to have continuous 6 degrees of freedom. You could have, let's say, 3 set positions. One of them is when it's underneath. So when you bump, it gets pushed all the way underneath. You don't have
can
to
do some clever mechanisms like that, and that brings it more into like if you ever visit a German type factory where they do very clever machine tools that just do one specific thing very well, it's that design philosophy, right? It's almost the opposite of robotic design philosophy, where robotics, you want to design the mechanics to be as general as possible and move all the intelligence into software, whereas the complex high-speed machine tool type philosophy is make the software as dumb as possible, but the mechanical components will be very specialized and do very complicated things. Like it's fun looking at YouTube videos for this stuff. Like I remember when I was in college, we took a field trip to a factory that makes link chains, right? The standard kind of chains with this kind of link, like alternating. Huge complicated machine that chops off like wire into equal segments, then has one stage that bends it into a U, then another that pushes the next link in, and it forms the whole chain, and the chain comes out. I wouldn't call it a robot. It's a very specialized machine tool. So it's an interesting philosophy for, I think, closed mechanical operation universes. If you have a very closed set of like operations you need to do, that's what you should do. But if you want to do extremely general purpose things, you would do the robotics thing, which is 9 degree of freedom.
Or not. Or not. Maybe you don't need that much freedom.
Usually there's a mix, right? A wheel is a very single degree of freedom type thing. I dropped the piece. So the problem about playing with Legos on a call, you drop things. Anyway, we can move on to the next topic. You guys had 2 things you wanted to look at.
Yeah, so I've been looking at some drones for some time, and then I found this. So there are a lot of ESP32 drones already. Wait, let me share the screen.
Oh, how do they handle the video?
Which video?
On the drone?
assuming it's a drone with video.
I don't remember seeing a camera.
No, I don't think this one has it. So Crazy Fly is let's say a standard research plat or like toy drone. So all the universities or research labs which do like swarm drone research basically are doing this on this one, but this is running on some Nordic or some other STM32 board or microcontroller. So now and then they have the entire stack, the computer or the desktop, and there are some other like control software to control this. So people have ported this to other platforms, and one of them is called Lightwing. I think it came out a few months ago. So and there are other similar ESP32. So ESP32 drone has existed for a few years already, and then somebody made a ESP32 S3 which we are using on the Tumblr. So yeah, like I've been thinking of buying this, and then it has some extra GPIOs for connecting the sensors you want,
Mm-hmm.
and then basically you could also connect the camera if you wanted.
How much weight can it carry? Is that sensors? So how much weight can it carry?
Well, it's carrying the battery, so battery is like
No,
200 kg.
additional weight.
I don't know the lift of these. So it depends on the BLDC motor you are using, I think. So total lift, I don't know actually. But this looks really nice. Like I might buy it at some point, but right now I don't have time to explore this. And yeah, all the circuit, everything is open source. So that's also nice. It's just $50.
Page is nicely detailed, huh?
Yeah, and it's just $50. So source code. Alright. So there is also a joystick to control it, but I think like if you have the joystick, then you could also control it with your phone by sending the command.
Yours, Venkat is competing with that Kickstarter. You're muted, Venkat. You're muted.
You are muted, Venkat.
Yeah. So this is also $50. I don't. I got it to hover.
A Lego drone?
Yeah, the body is made out of like Lego Technic parts, and it comes with like 4 different bodies basically with the same motors. So the motor and wire harness is like the main component, but then it gives you 5 different chassis to mount on, and then it has 1 battery, and I think it's an Arduino based microcontroller. But so far I haven't properly gotten it working. I got it off the ground once, but I didn't properly calibrate the gyro, so it's crashed. So I basically need to take it outside one day and properly do this.
How do you control it with the 2.4 gigahertz joystick?
Basic remote control type thing. Yeah, it's I think 2.4. Yeah, we should get into drones. Yeah, I was thinking actually once we do this first Yakusar tumbler design, we should design a second generation which is heavier and has more power and is like physically big enough to do things like this. Like the top deck should hold a drone, right? So I like right now I think our designs are like just a few watts, right? We can I think easily get up to like a 50-60 watt design and do a lot more. So it would be nice to spec out like the next level power.
Yeah, it could be on the same level as like the first rover I did, the ESA one,
Mhm.
in the first year, the same class.
Yeah, as I think I posted this on Discord, but I was thinking, yeah, if you get up to about 1 kilowatt power, then you can forget about like doing very specialized compute and stuff. You can just run a small server with like 150-watt standard GPU type hardware, right? 150, 300 watts going for AI compute, and then the motors actually beyond the point. The most expensive power drain is the computer and radio. I think the motors, since they're such low geared motors, they don't actually take up much uh, power, especially if you move infrequently and slowly. So the big power budget item is the compute. And I was looking the specs up on, I think, Perseverance or something. Yeah, radio communications over a long distance that are completely autonomous, that is really expensive. Like if you want the long range, reasonable bandwidth connectivity, and you're not piggybacking on something like the cell network, yeah, you're basically, that's the most power hungry component.
What? There's a cellular communicator?
Well, if you're on Mars, there is no cellular communicator. You're like either doing the hop through the Mars
Why
orbiting
not?
thing, and then there is a full direct to Earth link.
Have you seen this Iridium uh,
That's nice.
Arduino or like SparkFun? So it directly connects to the satellite.
Oh yeah, Iridium is the old sat phone network, right?
Yeah, so I think they have like small modules which they provide, and it connects to an Arduino. Uh,
Nice.
That's what I expect. I expect there to be a few satellites around Mars.
Yeah, but sticking to our nearer term Earth plans, I think we looked at, what was it, Particle.io boards, and then there was the Nordic or something. No, what was the name? There's a couple of options for radio.
the Blues networks, and then there is a Nordic
Yeah.
SIM, like a IoT product.
Wasn't there something called Particle or something?
Yeah, there is also a company. I think it's called Particle. I think it's a company called Particle. I don't know.
Yeah, Particle.io. Yep, Particle.io, application infrastructure for intelligent devices.
Bare metal runtime.
Oh yeah, this is yet another abandoned side project of mine, which is to finish that power electronics course from MIT and do the basic power budget of rover.
So yeah, it depends on like how we want it. So they provide the entire SBC with a cellular connectivity like this,
Mhm. Well,
and
some
then
of
it
us
has some AI.
bought.
I think was it Red who bought the Blues card.
Mm.
Then they also have this hat format, which goes on top of the Raspberry Pi.
Mm.
Oh, interesting. They have an RPi compatible one. Oh yeah, this is the sort of thing. The reason I was saying it's best to standardize on the RPi, like that robotics board you showed from that new company. The number of options to do things like this would be very limited, I think.
No, it was a 40 pin connector of the. So now everybody has standardized to the RPi 40 pin connector and the basically the dimensioning, all these
Oh,
hat format. So basically, even if you buy the that SPC I showed, or I think like even BeagleBone has started making the RPi form factor. So everybody has standardized to these 40 pins and then the dimensions of the hat. So you can
okay,
basically mix and match. Yeah, I was
and
looking
is
at
there
this
also
one.
standardization on like the pinouts and stuff? Like, do they
Yeah,
have to do
yeah.
consistent VCC and Z ground and stuff?
Yeah, so the RPi 40 pin connector is like a standard pin out now.
Oh, okay, nice. All right, that's good to hear.
So this pinout is basically standard now. So you will have SPI on these pins and power on these pins, PW, I2C on and UART on these pins. So it's like a standard now.
Oh, nice.
Mm.
And there are 21 GPIOs. Okay.
Why is the GPIO? Some of them have a big circle and some have a little circle.
I think the circle means a GPIO
It
and
looks like
small.
all of the little circles are ground.
Yeah. Basically, it's black colored. That's why you are not seeing it.
Why do you have so many grounds?
That
Yeah,
I don't know.
yeah. So why do you have so many grounds?
No, I don't know.
I don't know. In practice, it's quite convenient to have several grounds when connecting several devices, so that we don't have jumpers going all over the place to try to go to common ground. Just in practice, in my relatively limited trials of a dozen projects, basically.
Okay.
And I think this was the one which Yasha was suggesting, and I think Red has this. So it also comes in a Pi hat format. You basically fix this on the Raspberry Pi. The Nordic has this nice.
Were there so many hats like only a couple years ago? It looks like it's really become a standard.
Yeah, the RPi hat is now standard. So everybody just builds SPC in RPi format, and then the hats are also standardized.
Is there a practical limit to how much you can stack the hats based on like power attenuation or things like your line capacitance type problems? Can you stack like 10 high or 4 high? This is a ChatGPT question. I think I actually asked ChatGPT.
Yeah, I don't know.
About the answer.
I've seen like 4 to 5. So you know this M5 stack. So this is basically a stacking platform. So they make modular boards, and then you can stack lots of stuff on top of it.
M5.
So, M5 stack. So I've seen like 3 or 4 stacks in this, and
nice.
Yeah, it hasn't been a big issue for them, it seems.
Okay, ChatGPT tells me that the practical limit is about 3 to 4 boards before mechanical instability or header alignment becomes problematic. So that's the mechanical limit. But then, of course, there's also all the other things, like all these boards will be trying to use different pins and stuff. Oh, there's I2C breakout boards, or it's talking about something called a gadgetier style baseboard with 20 plus devices via expansion hubs. So there are options for doing a lot with a single RPi. I've never heard of this gadgetier baseboard. Okay, I'm not finding. Okay. Oh no, it's an old Microsoft technology that's discontinued apparently.
That's what innovation is about, right?
Too many
Creative
things.
destruction,
What is that other thing you posted? Maybe we should talk about that. There was some robot with weird wheels that somebody posted.
Maybe Maybe
Yeah,
it was the
talking about that.
the rover that the rover that where the link.
Yeah, you posted it, Eric. The Hackaday IO. Yeah, let's take a look at that.
It looked interesting for a quick chat. Like if you didn't have. Sorry, apparently my brother is challenged by something. Okay. So the link is in the.
I can share. Yeah, I
Sorry, I'm
found it.
sharing here.
Yeah.
So,
You can share my screen, Anurag.
yeah. Yes. I'm sharing also the
Oh, okay. Yeah, you
the
can.
Hackaday page where there is the information. So sorry. Yeah, here we go. So I think when you click what I sent, you get to this page. Okay. And it's a hobby project clearly. Okay, but a couple interesting stuff. Okay. So first, the goal. Okay, I think it was here to try to make something like completely printable. Okay, as much as possible. So just using screws and a brushless motor. Okay, I think that was here. Yeah, so TPU wheels, and after printing the wheels in TPU, the rest in some plastic, and after just a motor. And so there is a log, okay, a log of the
very nice.
experience. So just a few entries, but a few interesting things. Okay. Sorry, not this way. This way. So some will resonate with what we've done in this group over the past few years. So here, it's a planetary style differential. Okay. So Fusion 360, we don't use that. Okay. But very quickly, depending on the kind of plastic. So here, first using PLA and PETG. And so first the dents break easily. Okay, so with PLA we often see that in the past, and also it's melting here in the red.
Using a thermoplastic material for high loads causes it to thermoplast.
Yeah. I think it would work ABS. Usually they use ABS if they want some heat resistance, but yeah, PLA would melt with anything.
ABS is also more expensive and quite brittle. So I don't remember what anyway, it's a log, so we'll see. He solved the problem a bit later, okay? First, he modified the design of the what was it?
Planetary gear
Of this casing. So he moved to nylon, and also he put some inspection holes and stuff like that. So quite interesting to have such kind of incremental design. Okay, and after he explained that he tries many. So he goes through a dozen iterations here. Okay, so he showed them here.
Wow.
But in the end, he settles to something. Okay, but he doesn't say which one. Okay, so anyway, it's some other plastic and some combination. Okay, so that he jumped to the TPU, and that reminded me presentations from Venkatesh like a couple years ago. Okay, and so that went well quite immediately. Okay, so he used the something called the Michelin airless concept to design them. Okay, apparently for that it was pretty straightforward. Apparently for him, he mentions adding immediately some bearings to mount them on the rover. So when this was simple and pretty interesting that he also uses TPU to make springs. Okay, so there is the guide, the spring guard, and so his goal is to do printed stuff. Okay, so with TPU he says that so surprisingly it handles rough terrain better than I expected,
until it didn't. Okay. Unfortunately, there is. I tried to find more information about it didn't, but there is not much in this log. Okay. He mentions how he mounted the motor, so 45 degrees. Okay. So a few pictures of we can see the motor here, and here the transmission and the shaft. Okay. So it's also a quite big rover in the end. No? Okay. Maybe what a 40 centimeter long. So after there are the first trials, okay, so he does, so apparently there is snow, and so it apparently works quite well. We can see here the spring, okay, in action. Okay, so with the TPU pieces. Okay? So a couple pictures like that, but unfortunately, the rover slips apparently on stairs, okay, and so it breaks one of the wheel leg, okay. So I don't know what he used, but it may be PLA or something like that, and it's pretty brittle, basically.
Yeah.
So in the process also, there is a dent, one of the dent that breaks again. Okay, so the situation, if I get back to this slide where he reports finding a good one, so it's still pretty limited apparently.
But he seems to have lots of different parts that are suffering mechanical failure.
Yes, but I guess that so I have no idea what the motor he shows. The specs are here. Sorry for the scrolling here. A 775 brushed motor at 45 degrees. Okay. So I don't know, but if this motor turns out to have quite some couple, okay, well, it's brittle plastic. Well, the fatigue may break it pretty quickly, basically.
So he's only using a single motor and using a differential to drive it. So that's mechanically quite complex. I think every design we've looked at simply has separate motors for different wheels.
Yes, I see the ones you mean. But here he continues and actually creates a new, so a multi-stage planetary gear reduction. Okay, to try to deal with these breaking parts. So quite interesting design, and apparently he reports some progress on with that. There is little information in the end. Okay. After he replaces the straight wheel shaft by one of this shape. I don't remember how it's called. Okay, Venkatesh, you can help here. I don't remember how these joints are called. Okay, but we can see them here in on the later design. Okay, and I think at the end, so that's the last post, and we can see them here printed. Okay. And so the last report is that it's a successful disaster. So I think we like such kind of situation. Okay, so it works yes or no. Okay, we can see there is a camera mounted on it and so on. Okay, a camera mount not unlike the one that Venkatesh just live design. Okay, and so the car drove, spun, crashed, broke. Okay, and so each failure told something. Okay. And the conclusion, like plastic filament is not as good as metal. Okay. So anyway, just a small nice project with a bunch of interesting ideas, and we can see that every part is really printed really, right? Okay. So we can see also in the middle here, on the transmission, how wearing just goes very fast. Okay, because maybe it's after just one day of use.
Is he driving with exposed plastic transmission over fine gravel?
So I couldn't check quite exactly here because of the contrast.
Flies in and that's the end of it.
I'm not quite sure because I do. That's the front of the car and the front.
Even if you protected it, this would not last very long.
I agree, but this is
No,
impressive. I like
It looks like it. Oh, sorry. It looks like there is a bit more casing than just plain like that. Okay, but just to close it, but that wouldn't do anything for such kind of
Yeah, but then
basically.
it won't be air cooled. You know, you have the problem that it gets hot.
Okay,
So,
yeah, he talks about air cooling. Yes. Okay. For that, there is no more information, and I just discovered that this morning, so I don't have any more to say on this one. I just found a nice hobby project,
Yeah.
and also a lot of things we shared in our own experience, basically.
Yep. I want to
So
show you
that's it. Yeah.
one more fun thing. I just bought this kit. I don't know, have any of you guys made this kind of like kit? It's very simple. So it comes as a sheet of metal like this.
Ah,
Break off little
One of
all
my
right.
kids did.
Yeah, the construction technique is all these are flat, thin metal pieces, and you bend little tabs over them, and then you end up with a design like this. So this one should end up looking like the ferries that run on the ferry system here. So I just wanted to try this construction technique, and if I like it, this might be an interesting thing to try because I've been thinking like what's the easiest way to upgrade from plastic to metal, and really the only standard way is to like design flat aluminum parts and then get a machine shop to like cut them out for you. But I'm just exploring, are there other interesting techniques you can do to do metal? So I think the materials that are worth exploring beyond 3D printing is basically melamine boards, which can be cut with a laser cutter. So that's the kind of board that's on the tumbler. Wood, of course, is a good material within limited climate ranges, but metal, other than flat aluminum that's custom cut, this tabbed solution might be interesting. I don't know how you make these things, but I just thought you guys would be curious to see that. You can get really complex designs. This is one of the simplest ones, but you can get like basically anything. So this is a single sheet design. I was looking online. You can just go to metalearth.com, and they have really complicated ones like the F-22 and Artemis rocket and stuff. So that's what surprised me, that this folding metal tab construction technique can create that many complex geometries.
Very interesting to see what kind of technique they're using to design them, right?
Yeah. So it's kind of like origami, I guess, because you have to think about foldable patterns that then become 3D a little bit.
Right.
They use a lot of origami in like more complex space mission designs. There are things that like expand into buckyball type structures. So there's a lot of interest in origami based space structure design. Anyway, so I guess that's it for today's call.
Yeah, we have 1 minute past. Yeah.
All right. I'll try to actually design the fixture I rough sketched out in the next couple of weeks. See you.
Okay.
Great.
Thanks. Bye.
Thank you. Good night. Good day.
Good night.